Iron Man has always been one of my all-time favorite superheroes. Because his superpowers don't come from mutant genes or some terrible accident of science. They come from the genius of his own invention. It's one of the most iconic suits of armor the world has ever known. There's just one problem.
Can I get some help?
As good as this suit looks, it is still just a work of science fiction, a clever mix of plastic, glue, and foam, and a nice paint job, but it ain't real. And I want to make a real Iron Man suit. Yeah, I really do. In this episode, I set out to make my own suit of Iron Man armor from titanium.
I am so ready to fight crime.
One that can take a bullet, survive a bomb blast, and one that I can fly in. At least I hope so. This is Savage Builds. So, how do we go about building our own suit of Iron Man armor from titanium? There are, in fact, a lot of moving parts to this equation. First and foremost, we needed permission from the owners of Iron Man, Marvel Studios, for using their character. And with the blessing of studio president Kevin Feige, we got that permission. Thank you, Kevin. Then, we needed access to the original digital files that Iron Man's suit was built from. Specifically, I chose the Mark II prototype suit from the first film, because that's what we're building, a real Iron Man prototype suit. Those files reside at legendary Hollywood effects house Legacy Effects, and Shane Mahan and his team supplied us with all the digital files we needed to make our suit. My hat is off to you guys, thank you. But we hit a snag, because those digital files were meant to build a movie Iron Man suit. It's plastic, it's rubber, it's a long way from being bulletproof, bomb-proof, or titanium. So how do we get from there to our suit? Well, that all begins with me going back to school.
Welcome to Golden, Colorado, and the beautiful campus of the Colorado School of Mines. Not mimes, mines. In 2017, this was ranked as the top university in the world for mining and mining engineering studies. Things like ore and minerals and metals.
The person we've come to see, Professor Craig Bryce, is the director of the Advanced Manufacturing Program, one of the top programs in the country for teaching additive manufacturing.
You might know that as 3D printing. And Craig has a special present for me. It is an actual piece of our armor 3D printed out of titanium.
I've got something for you.
Oh,
Do you know what this is? I picked an easy part.
it goes right here.
Perfect.
Oh, dude. I'm not supposed to be speechless on camera, but I am speechless. That is gorgeous.
Do you want to see the rest?
Oh yeah, let's go.
Let's go.
Oh.
You are looking at 250 separate pieces of Iron Man armor that were 3D printed in titanium. Titanium is a natural mineral with the highest strength-to-density ratio of any metallic element. It's stronger than certain types of steel and a fraction of the weight.
So how do you print 250 separate titanium pieces of Iron Man armor? We were lucky enough to partner up with the manufacturer themselves, EOS, who makes the very printers that we're using. And they have been donating printing time on machines they have all across the United States for months in order to get ready for this episode.
All under the guidance of lead engineer Austin Isaacs.
Now I can hear you wondering in your head just exactly how these printers print in titanium. Well, it begins with a fine titanium powder to which you add a high-powered laser. The printer itself takes the digital file you want to print and divides it into thousands of horizontal layers. Then for each layer, it lays out a few microns of the fine titanium powder, and the laser comes in and draws that layer. And by drawing, I mean it melts the titanium powder in the exact pattern that that layer needs to be. Then it lays down more powder, and the laser melts some more. Multiply that process by thousands of times, and eventually you have grown a solid titanium part from fine powder.
The pieces were sent back to Craig, who, with the assistance of some dedicated grad students, got these parts cleaned up and ready for assembly. And that's where we are right now.
Final pieces.
Oh my God, look at that. Grad students Sarah and Jesse worked alongside Craig to help make this happen.
Wow!
As you know in Ironman, the iconic chest piece that lights up.
Yes, the palladium arc reactor that powers the suit.
Yes. So I made you a ceramic chest piece that's additively manufactured.
Oh my God, light comes through this.
Yes.
You are insane.
Let's be clear, our version of Iron Man's iconic glowing chest piece is strictly decorative. Our suit will not be powered by a virtually unlimited power source like the arc reactor. That is still very much science fiction. And unlike the titanium sections that we hope will stop a bullet, the ceramic piece is not bulletproof.
Got it?
Look at that.
There we go. That looks so good.
So I think we have enough for fitting you up with one arm, the hand, the forearm, the bicep and tricep, and the shoulder with the pauldron.
Fabulous. That sounds perfect. Oh, good. That's nice and solid. All right. Pinky. Thank you. I am so ready to fight crime. Hey, digital post guys, can you give me an effect here? Watch this. Amazing. Still a lot of work to do, but man, this is how to get inspired to do it. I am so gobsmacked by the amount of labor and time and love and energy you guys have all put into this. Here, let's shake hands. Oh, how does that feel?
Feels great.
It's time to bid a grateful goodbye to Craig and his team, pack up all the parts, and deliver them back to San Francisco to my team, where they can start the time-consuming process of putting this suit together. In the meantime, I'm gonna learn how to fly. From this guy. I am building a real-world titanium Iron Man suit, one that will take a bullet, survive a bomb blast, and that I can fly in, just like Iron Man. And how will I do that? With the help of this guy. Meet Richard Browning, inventor and chief test pilot of the Gravity jet suit.
What he's achieved is an actual flying rig that only weighs a couple of dozen pounds that a human can wear on their body.
I've always had a fascination and a real passion for flight. I had a background from calisthenics training, and before that in the Royal Marines Reserve in the UK. And that taught me a lot about the capability of the human body and mind when really focused on a challenge. And I thought, if I take that inspiration and apply it to how humans could fly, why not just go super minimalist and add just the right amount of horsepower to the human mind and body and see if you could approach the challenge of flight in that way? It's just one of those ideas that has ended up, well, really taking off.
It took Richard nearly 2 years to develop, test, and master the art of flying his prototype jet suit. And I'm going to attempt to learn how to fly it in just a matter of hours.
Walk me through the basics.
We've got a jet suit here which is made up of 5 jet engines, real micro versions of the gas turbines you have on a jet fighter or an aeroplane you go on holiday in. Now, the arrangement we've ended up with is 2 on each arm and 1 round the back. And if you imagine that really between those 5 engines, they create like 3 legs of a camera tripod. Rather than controlling the throttle of all of those engines, it's worked really well to do something called vectoring. The idea is, as you squeeze on the power, you're leaning forward slightly, so that rear engine is actually leaning back a bit. So that's that's 1 leg of your 3-legged camera tripod.
Oh, okay.
And then you've got the other leg here and the other leg here. And the idea is you squeeze on that power, and then as you bring the arms inwards, gradually all of that power is enough to offset your weight and the weight of the system. And that's when, as I'll hopefully demonstrate to you, you'll see my feet just come kind of effortlessly off the ground. So in terms of flight control, you accelerate the throttle to the preset power level that's required for your weight and the ambient temperature. There's some variability there. Squeeze that trigger in and you feel that power. Once that power is there and pointing outwards, you just start bringing it down, and as you vector down, you lift off. If you actually want to rotate yourself, all you're doing is just sort of robot arms kind of action, but you're just pointing a little bit of thrust backwards one way and a little bit thrust forwards the other way, and that will induce a rotation. If you want to go left, then actually just pointing your right-hand engines to the side will actually take you left, and the same the other side. The same with forward and backwards. If you want to go high, you keep vectoring down. If you want to come down, you flare back out, and then you just gently sink. Really looking forward to you having a go. Looks like you are too.
I am.
Yes, I'm excited, but I'm also not reckless. We'll be taking some significant safety precautions before I go airborne.
In a few minutes, I'm going to put on Richard's jet suit, under which I'm going to wear a harness because I'm going to be connected to a rope so that I may train to fly without the high stakes of dying in case I can't fly. All right, jump up.
Put your right arm in there. Can you feel under your thumb the kill switch, little button?
Yep.
Okay, and then feel the trigger as well. So pull the trigger, press the trigger.
My goal here is that Richard teaches me enough that I can fly untethered. Because if I'm going to be Ironman, I gotta fly without a rope, but I only have a few hours. We have the amount of time we have today for me to get comfortable on that rig so that I can try it in the Ironman armor. Honestly, I'm not sure how I'm gonna do.
There you go, that's your 1,000 horsepower of jet suit.
We're going to start at 50% power for my body weight and then increase the power output in 10% increments.
But it's enough to be able to feel the dynamics of, if you do that, guess what, you get blown that way, and your brain can start coding the action and reaction experience.
That is fascinating. It is a completely unique experience to have so much horsepower facing down from my arms. Strangely enough, it feels exactly like watching Tony Stark land. Like, it's... I am not very articulate right now because what I just experienced, I don't really have common words for.
And that was only at 50% power. Unlike the unlimited flying time of the Ironman suit in the movies, Richard's jet suit has about a 5 to 9 minute flight time depending on conditions before it has to be refueled, giving us a built-in break for some adjustments.
Each time we refuel, we just give him more and more power. Let's go.
Okay.
And essentially, that demands of him to adopt this vectoring principle of holding the engines out, feeling that power, and then controlling it progressively and bringing it down. Okay,
It takes a tremendous amount of strength. My left arm is actually giving out a little bit.
This certainly validates that it's not maybe as easy as it looks. Certainly to go from no experience to trying to fly in one day, this really confirms how challenging that can be.
This right here is one of the hardest skills I've ever had to learn. I taught myself how to ride a unicycle. Hell, I drove an Indy car and didn't pop the clutch. But none of that comes close to comparing to this.
So we started that last one at 100%. He's gonna have to learn to be able to hold that hover, and we should see that, but he's swinging everywhere. That does put into question his progress today, at least.
Yeah, you look tired.
I am
Yeah.
tired.
That's good, that's good.
I don't have much more time to learn this machine before getting in the Ironman armor. So frankly, at this point, I'm not sure I'm gonna be able to fly as Ironman. But that's my goal.
My attempt at flying fell a little flat.
This right here is one of the hardest skills I've ever had to learn.
Now it's time to come back down to earth. Before I can resume flight training, I need to jump back into the painstaking work of assembling the hundreds of pieces of the Ironman Mark II armor.
The Ironman suit is back in San Francisco, and it is assembly day here in the shop. We have a whole bunch of titanium parts, and it's time to get it all together so it will be wearable by me by the end of today. Here's hoping it all gets together.
With 250 individual parts, getting organized is key. The first step is labeling and sorting so we know just how everything fits together.
It's like this is the upper part and this is the lower part.
Next, we begin the assembly process, which starts with figuring out how to fasten the pieces to each other. Working with titanium poses a unique challenge.
One of the reasons we wanted to go with titanium is because it's super light and legendarily strong. But the difficulty with that strength is that we need to attach these pieces to each other, and no drill that we have in our possession actually even makes a scratch on this titanium. In fact, the only thing we've found that allows us to attach these pieces is this industrial hole punch. Check this out. This is how you make a hole in titanium. Right? But this isn't even the thickest stuff we have to deal with. The kneecaps are like twice as thick. I don't even have the hand strength, so we have to use a cheater. Yeah. This has been a journey.
After hours of hand-bruising titanium hole punching, we can finally start riveting the pieces together and assemble everything into bigger sections of the suit itself.
There we are. I am so ecstatic with the incredible group effort that it took to put this thing together.
So I'm gonna turn them on.
All right. Whoa! The number of people across the United States who galvanized their intelligence and their ingenuity and their cooperation to help us achieve this.
Yes.
All right, I'm done working today. I'm just gonna walk around with this.
In addition to being strong, titanium is also resistant to corrosion, cracking, and high temperature, and is used as a component in a wide array of military weapons, from airplanes to naval ships, spacecraft to missiles, and yes, armor plating. We're hoping our armor will be able to stop a bullet and survive a bomb blast.
Tony Stark's got some big legs.
But there is one major weakness in our suit. Please don't tell the bad guys.
While 95% of our suit is 3D printed in titanium by EOS,
it's not entirely titanium. And that's because titanium is really hard and my flesh is really soft. And in the transitions between the two, sometimes we need some other materials that are more, shall we say, forgiving.
In the films, the Iron Man armor is not only super strong, but amazingly flexible. A flexibility that's impossible to replicate in reality using 100% titanium. So we had to make some adjustments.
For instance, our abs here are actually made in a flexible urethane. This gives me some real range of motion. The shoes are actually 3D printed in powdered nylon, a material I am kind of surprised how robust and resilient it is. This is printed by a company named Dinsmore Incorporated. Thank you guys for that donation.
As we close in on finishing our assembly, I'd like to separate fact from fiction here. Tony Stark's suit is a fictional piece of engineering. It has a built-in life support system. It makes him super strong. It's practically indestructible. It has an arsenal of advanced weaponry, and it can fly. The military has been trying to develop a suit like that for decades and hasn't even come close. Our real suit is basically a titanium shell. We hope it will be bulletproof. We want it to be bomb-proof, and we plan to try and fly in it, but it won't be the fully functional suit we see in the films. But to my eyes, it is a thing of surpassing beauty. And after days of laborious assembly, it's finally time to put it on.
Squeezing in. Beauty. Great. Awesome.
Yeah.
And finally, I am Iron Man.
I can't even tell you how awesome this feels. I've been wanting to put together an Iron Man suit for about 10 years, but I never in a million years imagined that I'd end up with one made out of titanium. I swear, this thing, I'm hitting. Yeah, I feel pretty well protected in this baby. Other thing that I find really exciting about this titanium suit of Iron Man armor, there is only one in the world, and I am wearing it. That is freaking cool. The next thing to do is to start shooting this thing with guns and see how bulletproof it actually is. All right, let's get a can opener so I can get out of this thing.
I said at the beginning that my quest was to create a titanium Iron Man suit capable of 3 things. It had to be bulletproof, bomb-resistant, and one I could fly in. It's time to test the first of those super abilities.
I am standing in the Alameda County Sheriff's Department shooting range in Dublin, California, where we are planning to shoot some guns at our newly completed Iron Man armor to find out if it's bulletproof. And if it is, well, then it has crossed that divide from costume to real armor. I'm kind of excited to find out. It's like a cooking show, but with guns.
For today's test, my team and I constructed a remotely operated gun stand that will allow me to pull the trigger from behind a shield to avoid ricocheting bullet fragments. We'll be firing multiple calibers of bullets to test the armor's resistance to increasing impacts. A 22 caliber, a 9mm, and a 45 caliber. Think of them as small, medium, and large.
Awesome. I feel like that is in a good position.
The impact of a bullet is determined by the projectile's mass and velocity. The bigger the bullet and the faster it travels, the greater the damage done to the target. We're hoping the bullets won't penetrate our titanium armor, but if they do, we want to be able to measure the damage. Cue the dummy.
Right here, right there. Perfect. We found this company that makes ballistic gel dummies with bones and organs that have been calibrated to be the correct density of proper organs.
And as you can see, this one is slightly used.
All right, get the armor.
We'll be firing all 3 of our different caliber bullets from handguns at a distance of 20 feet, close enough to inflict mortal damage to an unprotected human torso.
Safety is off. Here we go. Gonna shoot at some Iron Man armor. Oh. All right, buddy. See you on the other side. Here we go. 3D printed titanium Iron Man armor versus 22 caliber bullet in 3, 2, 1. Oh, there is no break in the surface. There is no dent, no nothing. I can see the mark where the 22 caliber hit, but there is no tactile sign that a bullet hit this, and that means that this is bulletproof. But it's a 22 caliber round. I would like to fire some higher firepower at it to find out just how bulletproof it is. I can't believe I just said that sentence. We're moving up to a 9mm round.
It's not just bigger than a 22 caliber. Because it packs more gunpowder, it travels at a much greater speed.
There we go. We're hot. Here we go. 9mm round versus Iron Man armor in 3, 2, 1. The cover for the light fell out, but let's go check out how we did. Oh, okay. Wow, I hit right next to the other shot. A tiny dent. I mean, I can feel it, but it's probably moved in less than a millimeter. That is impressive. And you can see the bullet hit here and sprayed this way, and the amount of force actually knocked the lens out of the chest. This sort of thing happens from time to time. A close examination of the armor post shooting at it is revealing this here, a little bit of shrapnel in the ballistics gel. And if I pull that out, I can confirm, yep, that's a piece of lead from the bullet. And this is apparently one of the hidden dangers of wearing Iron Man armor, is that as the bullet splashes off your chest, if you don't have proper neck and chin protection, well, all the pieces of that bullet have to go somewhere, and they're going to enjoy burying themselves into your tender flesh. Now we're gonna move up to the bigger bullet.
With 60% more mass than the 9mm, the 45 caliber bullet is capable of much greater damage.
All right, safety's off. Here we go. 3D printed titanium Iron Man armor versus 45 caliber bullet. 3, 2, 1. This is a hell of a hit. Let's go check it out. Whoa, some significant, yeah, it came up and hit the shoulder bell, hit the pauldron, but seems to have skipped right off of it. Right there, that's a 45 caliber bullet hit, and it hasn't even left a significant mark. That is bulletproof armor. In the movies, you're always seeing Tony Stark in the Iron Man suit while people are shooting at him and the bullets are just bouncing off of him. We have now determined empirically, experimentally here at the shooting range that that is an accurate picture of what a titanium Iron Man suit would do in relation to bullets. It's totally bulletproof. Now we're gonna find out if it's explosion proof. So, we have successfully built the suit of Iron Man armor from 3D printed titanium, and we have determined that it is bulletproof. But bullets are only one of the things you see Tony Stark survive in the suit. You also see explosions constantly going off right next to him, and he is relatively unaffected. So the question is, can our Iron Man suit protect the wearer from an explosion?
First and foremost, I think it's important to go into what kills you in an explosion. The first thing that kills you is the shrapnel and the fire. But if you survive both of those things, you can still be harmed or killed by the blast pressure wave. That is, as the explosive is expanding, it creates a front of air moving at an incredibly high speed. And when this pressure wave goes through your body, it moves every atom of your body a few microns at well past the speed of sound and turns the inside of you to jelly. It's awful. So how do we test whether our armor can protect a wearer from that? Well, that's why I'm standing on the bomb range in Alameda County right now. This is a burst disc. It's made by a company called Osico, and these burst discs have been calibrated to burst at anything over 75 pounds per square inch of pressure. And that is an amount that we have calculated as a pressure that would definitely kill you if you received it near an explosion.
4 is really close.
Builder Jen Schachter and I will place the burst discs at 3 feet, 4 feet, and 5 feet from the explosion. The farthest disc that ruptures will determine our death zone. Then we'll repeat the explosion with the Ironman armor in that death zone. For our explosive, we're using C4. It's a plastic explosive detonated by transmitting a small electrical charge through a detonator cord to a blasting cap, a shock that triggers the explosive material. This is serious stuff. A military-issue block of C4 weighing just over a pound could demolish a truck. We're using about a third of that, a golf ball-sized chunk potentially lethal to an unprotected human.
We're ready for the blast when you guys are.
3, 2, 1.
Oh, we lost one of our burst discs. It just popped right off the stand.
Watching the high-speed camera, you can actually see the detonator cord deliver the charge, which in real time took less than 40 thousandths of a second. You can also clearly see the shock waves that hit all of our discs.
Let's check this one out. All right. Oh, you got the GoPro and everything.
Hello.
The 4-footer and the 5-footer are both not burst, so this is our death zone, 3 feet.
Now that we have used our burst discs to determine the perfect death zone, the distance at which the blast pressure wave would kill you, it's time to put our Ironman armor in harm's way. And to do this, we're using now 4 burst discs. And we're going to place 2 of them inside the armor and 2 of them outside the armor.
Let's go 3 feet.
Perfect.
Awesome. And after we detonate, what we're looking for is any difference in behavior from the ones that were inside to the ones that were outside.
After all the time and effort that went into building this suit, I can't believe we're about to do this.
3, 2,
Come on, Iron Man.
1.
Wow!
He's still standing.
Yeah, his head's still on and his body's still there. That was a really good thud. Excellent. We're all clear. All right. Well, look, on first pass, the suit itself survived the explosion admirably. The helmet did great. We lost one of his ears.
Oh, we lost both ears. His right ear
we
is
did?
way over here.
Oh, no wonder he can't hear. Let's pull the chest off.
Oh.
What is it? These 2 burst discs outside the armor fully burst all the way through, as we would totally expect. But the inside one is unmarked. So clearly the armor rendered a lethal explosion survivable. I have to say, when we started down the path of this project, I had no idea how elaborate it would get, and I really did not expect this material, the 3D printed titanium, to perform so well, be so resilient, and to have these incredible material properties that it is continually demonstrating. But before we call this an official superhero suit, it needs one final test of its efficacy, and that is, of course, flight. We've tested our Ironman suit against bullets, explosions, and now it's time for the final challenge, defying gravity.
Today is the day I am putting on the Ironman armor and hopefully flying untethered.
Last time he was on the tether, he made really awesome progress. His balance and stability and control was really coming together. What we're hoping to see this morning is that he can actually get up and hold a sustained hover. And if he manages to do that and land it several times, then we can consider taking him off that tether and then potentially adding that armor. Arms in.
All right. Good.
All right.
That was good.
I feel kind of optimistic that I'm actually going to be able to maintain a hover in this next flight. Somewhat optimistic. Somewhat. I'm going to hedge my bets there. It's tremendously hard, and the hard part is also figuring out how to be smart, not strong about it.
Your arms are quite out in front. If you bring them around here a bit, you'll be vectoring more downwards.
Okay, good.
That's one little tweak you could do.
Okay, it's clear that the technique is about the geometry of the operator, not about the strength in their arms. That was incredible. I was able to hover and stay hovering, and it felt like every dream I've ever had of flying.
That was epic.
Yeah!
Not only did you sit up there, you navigated back to
I did! I was able to look over and I was like, come on back down!
Brilliant.
Oh my God.
That's awesome.
That was so much fun!
So
Am I still yelling?
yeah.
Can we do one more?
Yeah, absolutely. Well done.
Thank you, handsome. Woo! Whoa, there's no way I should fly in the Ironman suit.
I'm not hurt, but if I wasn't tethered, I could have been seriously injured. I'm not sure I want to admit this, but at this stage of my flight training, flying untethered in a suit of Ironman armor is probably a bad idea. The real goal is to make sure everyone is safe. I think the last thing I should do at this moment is strap another 25 pounds of titanium onto my body and take off my tether and try and do it. I don't think that's safe at all. The goal here wasn't for me to fly the suit. The goal was for the suit to fly. So I don't mind that it's not me flying, and so I'm calling it. I am not going to pilot this Ironman prototype suit. Richard is going to be our pilot. All right, powering up.
That is brilliant.
You look amazing. So do you think that you can fly in this?
I reckon I can.
All right, well, let's get to it.
Ladies and gentlemen, I present to you Iron Man. Richard! Our prototype works! This was a titanium bulletproof Ironman suit flying through the freaking air. There's nothing fictional about the operation of this. It is a first prototype and it is raw as hell, but it worked. The hundreds of person hours and passion that went into bringing that moment to fruition, it's really incredible. I'm a little verklempt right now. Everybody come over here. Let's have a big hand for Richard and the team from Gravity. The first prototype working Ironman suit. It is so much of a group effort that brought this across the line. Craig, unbelievable. We couldn't have done it without you and your students. Austin, that was beautiful, man. All right, beer all around.